Our project is the cold combustion rocket system with thrust vectoring. I'm Antonio, this is Jonathan, this is Pablo. So as far as what the problem was, we partnered with the Mechanical Engineering Student Aerospace Society, and what they had to design was a rocket nozzle that used a type of thrust control called thrust vectoring, which is the addition of fins to control the direction of the exhaust. And this method was chosen because compared to the other designs, which involve adding either extra thrusters in this case, or heavier thrusters in this case, a fin is lighter and it's easier to control. So as far as our goal, we were in charge of designing the control system, be able to get the rocket to start and stop and navigate. In our case, a two-dimensional course. It was too complex to actually build a rocket to go up. That would have taken more than a year.
All right, so as part of our design system, we had to calibrate the rocket in the beginning. We also needed valves to regulate the pressure and the airflow. We also need to supply large amounts of power for each component, especially the solenoid valve and the brakes. We also had to do a Bluetooth communication between a controller and then the rocket itself, and also implement autonomous control using computer vision and object detection. So as part of our hardware components, we do have an Arduino Omega on the rocket, and then we have a Uno as the controller, and we have Bluetooth communication for both, so we're using a Bluetooth module. We have a solenoid valve, which controls the flow of the fuel. We have a servo at the back, which is intended for turning. That would be what would move the fin and then we have linear actuators, which are placed on top in the front. That's the brakes. So they're on a pulley system, and when they retract, they actually pull the brakes in the front. And then finally, we have relays to provide the power for each of these components. So as our cost, we are working with the mechanical engineers, and overall we had a total budget of almost $5,500. Our budget was $1,800, and we actually only used $543, which is less than a third of that. So we actually tested this with compressed air, doing a static run. So what we did was we paired the Arduino controllers using Bluetooth, and then we tested the servo control. So using this joystick, we could actually just turn it, and then the servo would respond. We could also open and close the valve, which controls the flow of air. The way I would open and close is by pushing this button, so I could actually just click it. And then the last test we had was our emergency stop function. So this push button on the breadboard, as soon as I push that, what would happen is the valve would close, stopping all fuel from going through, and also the brakes would retract to stop the rocket. So
Oh yeah, we can show our demo of the systems.
Go to camera. Can you go to camera? Sure. Is this the camera?
Okay, so go ahead and describe what.
So this is our controller right here. Right now we just powered on our relays, which control the actuators right here. We need an AC for the actual servo up here. So that's on. And then finally, I could actually move this joystick. So if you go to the servo, like here. So if I go forward, it should be moving now, let's see. And then similarly, if I turn, well, anyways, we could hear it move. The next thing I could test is the valve. So if I push this button, we'll open and close the valve. So we could actually hear that switch. Right now we don't have a fuel connected, obviously, but that sound we hear is what's opening and closing the valve. Lastly, I could push this button, which is the emergency stop, so the valve would close and the linear actuators would retract and pull the brakes. So, and then the rocket would come to a stop.
So for our project, we decided to use OpenCV for computer vision. This is used to process images in real time. Our intended usage for this was to help navigate through our 2D course, which would have cones on it, and the camera would be used to detect those cones. The code was run on C++. So here we have a demo of a cascade classifier, and see it detects faces. So it was working on the Pi, but we tried to implement our own classifiers for the cone. Unfortunately, it was a little bit difficult. We tried a whole bunch of methods to train it, and every time we trained the data set, it would take about 20 hours for a HAR. The LBP cascades, it would take a lot less time. However, it was still a little bit wonky. The image would not be recognized too well. However, we did get it to work a little bit well. But at first, there were a lot of false positives. Sometimes there would be thousands of circles on the screen, which is not good.
So we mentioned the 2D course earlier. In our case, what we had designed was for the camera to recognize where a traffic cone would be, which would indicate the end of our path. So we would have the rocket just travel in a straight path. Once it finds the cone, that's when the stop function would go and shut the fuel off and engage the brakes. But as Jonathan said, we had a lot of difficulties with getting the camera to actually recognize the traffic cone.
So whenever I tried to run our train file for the traffic cone on the C++ code in OpenCV, using OpenCV, the Raspberry Pi would keep freezing, and I would take out some components connected to it because there would be a power shortage indicator on the Raspberry Pi, and it was a really big issue. For some reason, it would not freeze with pre-built libraries, but we wanted to use our own cones, and it didn't work. Another thing, we didn't really have fins to control. It takes a while to fabricate the parts. We only actually got the rocket, we only mounted our stuff about 2 weeks ago, so it was hard to test.
Yeah, that was one of the challenges with working with the mechanical engineers is that the things that they have to build takes a lot longer than us simply having to program something. So initially, our timetable put us at about early April when we should have started testing, but delays in manufacturing and things like that kept pushing us back further and further. So our final product that we have here and that we took to the senior design competition is our rocket dubbed Woody's Windpipe. We couldn't bring any gases in here to do that kind of a demo. That would have also been dangerous. So here's our first live run. So I'll say the suspense, but long story short, it was unsuccessful. Like we said, we just got the entire product a couple weeks ago. Another challenge, unforeseen challenge, is that dealing with those tanks of air, they take a long time to refill, at least a day, depending on where we had to go and get them filled. So we're hoping to maybe do a couple more runs, get a real video for you guys in the coming weeks, but what we're really proud of is that previous projects with SAS only focused on designing a single part, and this is the first time where we've had a complete product. We can say that our control system worked in testing, it worked in the static test, it just didn't work in the live test. So in the future, we'd like to implement the kind of image recognition that Jonathan was working on to the fullest extent. One of the things with cold combustion is that mixing the fuels lets us ignore the heating aspect of it. So we don't have fire, we don't have anything near the components that get hot besides the components themselves. So if another team decides to switch from cold combustion to actual combustion, they might have to keep in mind where that heat is and making sure the components don't get too hot. So that's it. Are there any questions? Yeah.
So maybe you mentioned this, I'm sorry if you did, but do you know why the object detection failed?
I'm not too sure because I was trying a whole bunch of tutorials and they kept saying maybe increase sample size, there were a lot of ways in which you could probably resize the input pictures.
How big was your training set?
Well, I tried doing a small training set, but I tried doing like manipulations using like fabricating more samples from samples. So that may have been an issue too. But I did use things that couldn't. It did work for training, but it just did not do it for good.
Any other questions?
Other questions? Thank you.